Is that king? I don't even know. Alright, in this video I'm going to cover some of the, really quickly, some of the basics of, or I shouldn't really say basics. I'm just going to run through very quickly how one can use something like Hypermesh to help do some pre-processing for the one-dimensional elements. I have lots of other videos that do 2D and 3D stuff, but not so much on the 1D. And this is going to kind of assume that you've looked at least at the 2D ones and gone through those. So I'm not going to get into all the things of what are collectors and the menu panels and all that sort of concept stuff, but just kind of plow right through it. And you can try to follow the menu clicks, and for some of you that'll be quite fine. Okay. All right. So the first thing we're going to do is import in the CAD geometry. So if you've got release 13 or 14, you installed all the parts of the installation, you should have the ability to import directly a PRT file. So you can do it through File, Import, Geometry, or it's this icon here. You can pull it down and do Import Geometry. So the first window here, you can just select the file type. It'll try to automatically detect, or you can use UG, which is for NX. It used to be Unigraphics. If this doesn't work for you, like there's an error in the actual import, you can try using an IGES file, but you'll have to export the geometry from NX as an IGES file. And that always works, but sometimes some computers have a little bit of an issue with the automatic installation, importing of the Unigraphics parts because of the way they've been installed. But it works on mine, and it's worked on previous releases. So you open up the file window and you pick your file. I've already done that, and that's here. And there's import options, but the default ones should be fine. And then if we hit import, there is my CAD geometry. It looks a little different because it shades a little differently. You can click down here and actually, do the rendering, but it comes in as a solid, so it recognizes all those items as solids. All right. If you look under model, you can see that it's already defined a component. It calls it bicycle fork because that's the name of the part, and there's a coordinate system that comes in with it, and that's coincident pretty much with the coordinate system, the global coordinate system. I guess that comes through the PRT file. Okay. So I don't really need the solid geometry of the tubes, but what is important of the most use is the center lines of the tubes are there. So that's actually what I can mesh. All right. So you can see actually the center lines of the tubes, and that's what I'm going to use. Now, let me first go through some of the steps of defining the property cards and the material cards. Okay, so I'll do that real quick. So the way I usually work in this model tab, and by right-clicking in this entities window, I can usually create most of the things that I like to do. So that's mostly the way I work, although you can also use these menus up here. But again, if we right-click in the entities, the first thing I'm going to do is create a material. So we do create material, and we'll give it a name. We'll call it steel. It goes in there. And then, this is a newer feature. If we look down here, you can actually see some of the settings that go into the cards. So we can say whether it's a mat 1 or a mat 2. We'll stick with it to be a mat 1. We can put in the value for Young's modulus, so that's 30 each to the 6th. And we can also put in the value for Poisson's ratio, so 0.29, 0.3 for steel, and that's all we need to do. So that's in there now. Okay, if you do want to right click on it, I think we can do card edit, and here you can see it in the card form as, it would show up in a Nastran input deck. And if you wanted to add the strengths on the continuation line, you could do that. So you could say, I think it was 60,000 was the yield, not 6,000, but 60 E3, compression 63, shear, well, if it's 60 E3, it's probably around, it should be 30 E3 for yield if you're using like Von Mises, okay? Fine. And we also need to define some property cards. So you'll have to define different property cards, obviously, for different parts. So again, create, right-click, property, and down here you can select whether you want it to be a P-bar, P-bar-L, P-beam, PBL, right? Those are the ones that be relevant. So I'll use P-bar-L. You can ignore that one. Assign the material to be the steel. Just clicking through. And then the cross section's a tube. You know, again, I'm assuming you've looked at the user manual and understand how to use the P-bar-L card. And we put the 2 dimensions in. That's the inner and outer radius. So like 1/2 of an inch would be the outer radius, and then the inner radius would be 0.45 or something like that, right? Okay. Obviously, I think those are incorrect, but you put in the ones that you need to. Okay, so now we have steel and property. Probably not a bad idea to rename it to be like OD 1 inch, right? That tells me what type of property that is when I go to sign it. You can also give it a color, and that'll allow you to identify whether or not the elements have been assigned the right property or not. Okay. Now, to actually create the elements, so now we've got the material, we've got the property, and now we need to create the elements. These are all going to be one-dimensional elements. So when I go to create elements, I usually use these radio buttons down here and this bottom panel, although you can, I believe, pretty much do all this up through here as well. But I like to use this one. So I go in here under 1D, and you can see it has options for bars, rods, rigids, RBE3, springs, blah, 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 blah. Now, you have to remember that Hypermesh is meant to pre-process for a variety of finite element solvers, not just Nastran, not just OptiStruct. So a bar could mean a variety of things depending on what program you're pre-processing for. So we've set our preference here, I have, under user profile to be Nastran, okay? But still, a bar element, if I go to create a bar element, you'll see that it wants, in my particular setup, it's setting up a default as a C-beam element, okay? So I would change that to a C-bar element. I can assign the property. And here I pick the nodes. Now, unfortunately, I don't have any nodes here, so I can't pick those. Here I would pick the orientation vector. I could also pick the element offsets, right? This is the offset from the grid points to the neutral axis at node A and node B. And I can also set the pin releases at those. So it has all those capabilities. And we'll make one, and we'll basically check the card and see that it matches the C-bar type of stuff that we're used to seeing. Okay? All right. Well, before we do that, we need to actually create nodes on the center line. So to do that, I go under geometry, and you can see that there's nodes. These little X's here, these plus signs, they're not nodes, they're actually what are called points. And there's a subtle difference in Hypermesh between a node and a point. A node is something that goes into a finite element mesh. A point is assigned to geometry. All right, so the easiest way to do this is to use this option. This is the one that allows you to put multiple nodes on a line. So for example, if I pick this line here and I set it to 3 and then create, it will create 3 evenly spaced nodes on that line. Likewise, you can pick this curve and maybe you want to put 7 on there. And there's 7 nodes. All right. Okay. These big yellow things are actually what are called temporary nodes. They're not nodes until elements have been connected to them. Not nodes in the sense of a finite element node, but but they're temporary nodes, so you can use them for construction. All right. So let's create a couple of elements. So again, we're going to do it under 1D. All right. We're going to create a bar element. Remember to make sure it's C bar element. You can change them, but it's kind of annoying. Set the right property card. We're going to have the offsets all set to 0. The no release degrees of freedom at the nodes A or B. But we do need to define the orientation vector. And let's say for this one, since it's a circular cross section, we just need something that's not collinear with the center line the line defined by connecting the 2 grid points. So X and Y will have some that'll line up with that. So I'll just pick Z. So I'm going to pick the orientation to be the Z axis. And now we can pick node 1 and node 2, and that created a C bar element. We can do another one from here to here, and then one from here to here, and then one from here to here, and one from here to here, and so on and so forth, right? Mesh all those guys up. Right? And they are in the auto directory, and if I turn off the geometry toggles here for the bicycle fork layer component, you can see the elements are there, right? So these are the C bar elements. Actually, if we change the color here, we can make it something that stands out a little bit more. We can give it a better name, right click and rename it. We'll call it fork mesh, I guess. And here you can see if we do return and pick this icon, which lets you do a card edit. You can do a card edit, set it to elements, so we can do a card edit on an element, and you can pick one of the elements and you can see the quantities that would go into the input deck, right? So that's element 1, property ID 1, connects grid point 3 to grid point 2. Here's the orientation vector, it's in the Z direction, and that's as we expect, okay? All right. Now, you can go through and create this mesh, and you can fully assign all the load cases and everything that you would need, but let me stop here. I don't want to do the whole project for you. The other option that you can do is you can export this as a PDF file and then work on it manually and assign all those things, but use this program just to develop the mesh, okay? So I'm going to pause this video now and I'll do a second part of this, okay? And now the second part we'll pick up and we'll do the exporting and some of the load conditions, all right? So I'm going to do this video just to show you how to basically import the bicycle fork in and start to create the mesh. I'm going to assume that you've looked a little bit at some of the Hypermesh background information, some of my other videos that go from a more elementary level and talk about collectors and sort of the layout of the interface and all that sort of good stuff, and user profiles and everything like that. So this will be relatively quick, but it'll be very specific to this bicycle fork project. Okay, so we've loaded up Hypermesh. We're going to set our preferences to our user profile to Nastran if we haven't already done that. And let's import in the CAD geometry. So to do that, I usually do File, Import, and it's going to be Geometry. So you pick the geometry. This window shows up. File type, we're going to set it to Unigraphics because UG is for Unigraphics, and Unigraphics used to own NX, so that is actually NX. If this doesn't work, Sometimes there's some issues on some installations. You can always do an IGES import, but you need to generate the IGES file from NX first, okay? But for my installation, UG works for automatically reading in part files. Then you click on this little folder icon and you get the typical Windows menu select, find where it is. I've already done that, so here it is. There's other import options, and usually the defaults are quite fine. So we just hit import, and here it goes. So here is the CAD geometry imported into Hypermesh. It brings in everything as solids, but it also brings in the center line. So we're going to mesh the center line, so actually that's the most useful. All right. So if we click this tab back to model, it gets us the view we're more used to seeing. All right. All right. So now that we've imported in the part file, let's start generating the model. So although you can do this in almost any order, I always find the most logical way to think of this and to explain it is to first make material cards and then make property cards, because property cards refer to material, and then after that you can create the elements, because the elements are going to require the property cards. Okay, so first let's create a material card. So when you write the, again, you can do this often through a lot of the menu picks here at the top, but I usually use this panel here and right click and hit create, and that pretty much, I can make most of the model through that. So if I right click and hit create, I can pick a material. We get this little thing showing up here, and then also the input fields down below. So I'm going to call this steel because it's steel, and go down here to input the properties. This would be Young's modulus, which would be 30 e to the 6th, and then we'll also put in Poisson's ratio, 0.29. And now this card is assigned those properties. These are all the fields. You can see here that these fields do pretty much correspond to the Nastran input stuff. If you want to see it in more of the Nastran format, you can right-click on the steel card up here in the Entities menu and select Card Edit, and here you go. So if you wanted to add in the tensile strengths or the tensile design conditions, the compressive ones, and even the shear ones, which I guess would be about half of that, right? You can do that or not. It's up to you, right? But you can edit the cards directly in there. Okay, now let's make some property cards for some of the tubing. So let's create a property, and we're going to make a P bar L property. You can use P bar L. If you're going to use beam elements, you can use P beam or P beam L. So let's do P bar L. You can ignore this warning. And this assumes that you understand how a P bar L card works. Go down here and we can specify the material. That'll be the steel. And then the type of section is going to be a tube, and that means there's 2 dimensions, so we can type in the 2 radii. I don't know, I forget what they are, but one tube is about 1 inch diameter, so we're going to use a 1/2 inch as the outer radius, and I think the wall thickness is like 60 thou, so that would be 0.44. It's roughly the inner radius. Okay, remember those are radii. All right, so now we've got the steel and the property card. Now we'll make probably a couple different property cards, so it's not a bad idea to rename this to be something that's a little more relevant. So I'll call it like tube 1 inch OD, right? And we can even change the color so we can render the view by property and see which elements are assigned which properties. Okay, so we've got the material and we have the property card. All right, now we're going to make nodes and then elements. Okay, so although you got the lines here and there are these things here that look like nodes, those are actually points, and they're a little bit different than nodes, but it's pretty easy to create the nodes on those existing lines. So we'll go into geometry, and you can see down here, now for creating geometries and operating on geometries and making elements, I pretty much work in this panel. Although again, I think most of that stuff is also up here as well. So if we're going to go to geometry, we're going to make some nodes. So I click on the node button, if you would, subpanel. And then there's lots of ways of creating nodes. You can put in coordinates. You can put them on points. Actually, I've never done that. I wonder if I can put them right on points. Doesn't, okay. You can put them at the center of circles, in between points, intersections of lines. But for us, the easiest one is this one right in the middle, which puts several nodes on an entity like a line. So either lines or surfaces. So we're going to use lines. And we'll put, let's say, 2 nodes on these lines. Whoops, I guess you can do one at a time. Okay, we'll put 2 nodes on that line. That puts them at the endpoints. Whoops, not that one. This line. Maybe this line. And then on this arc, let's say we want to put more because we want to kind of conform to the arc. So let's say we put 7 in there. So if you put the arc there, it'll create seven temporary nodes, big yellow nodes that you can use to construct elements, okay, or connect elements to. And obviously, we would do that also through the steering tube and onto the handle. All right. Okay, so now you have the nodes. Let's make the elements. So these are all one-dimensional elements. So we're going to click on the 1D radio button, and that'll give us lots of options for creating one-dimensional elements. It's important to remember that Hypermesh supports several types of finite element solvers, not just Nastran. So these are kind of generic names. So you can change around the mapping of those from the element types button. So here you can see by default, if you pick a rod element, it's going to make a C-weld. If you pick a bar element, where's the bar element? It's going to make a C-bar, okay? If you see, it might say C-beam, but you can change that. Now we're going to make bars, so I go and clicked this button here, the bars one, and although it doesn't look exactly like the Nastran input card, it's pretty similar. You can see it gives us the provision to pick the 2 nodes, the orientation vector, the property, the type of element, C-bar or C-beam, as well as pin releases and element offsets. So for us, we're going to use the 1-inch OD property card. It's going to be a C-bar element. I'm going to use the orientation vector as the z-axis because it'll work for most of these elements, and it's a symmetric cross-section, so I don't have to worry too much about aligning them. And there's no pin release degrees of freedom, so the ends are going to be fully coupled to the next element. So let's pick node A and node B, and you can see there it created a C-bar element. Not only did it do that, it created a new component which it put the mesh. So I can just rename this fork mesh, and there it is. And we can go through and create the other elements. Just go through and click the nodes, and there you go. Something like that. All right. So now you have a mesh. You can actually check the elements if you want. This little thing that looks like a couple of like manila folders stacked up, that's the card edit. If you change this to element, you can pick an element and say edit, and then it'll show you basically the input deck, okay? I don't want that off the option. All right. Okay. So that's pretty much how you can go about making the geometries you need to. At this point, I'm going to stop this video. You can make the mesh, you can make the model fully in Hypermesh. You can go in and create, under analysis, create constraints. You can also create forces. And you can also create the necessary load steps, all in here, and export the file. Most of that stuff is covered in my other videos, so please look at those if you're not familiar with how to do that. But I basically wanted to show how you can start to at least make the mesh, import the geometry and make the mesh in Hypermesh. All right. The last thing I'm going to do here is just export the BDF file. Now, I'm going to do that at this point because you can actually create the mesh in Hypermesh, export the BDF file. And if you want to add in all the forces and the SPCs and the load steps by hand, directly on the BDF, that BDF file that gets exported, you can do that, okay? So I'll just export it here. Or you can make the whole model in Hypermesh and export that final BDF and run that in Nastran. Either way is fine. So here we're going to do export, solver deck. Again, it could be under File, Export, Solver deck. And we're going to give it a file name. We'll call it, I'll put it up here, and I'll call it Bicycle Fork, or Fork. And it's a Nastran format, standard format. We're going to export everything. And here we go. We're going to export. And that should have written the file. If I look in my directory, that should be up here under Applied FEA. I think it's Homework Solutions is where it was. You should see a fork somewhere in here, fork.bdf. And I don't want to run it, but I can right-click on it and open it in my text editor notepad. And you can see it's not a full Nastran file, but it's got all the elements and the nodes and the properties all assigned. So I could go in here and, for instance, you know, like it left out the solver card up top, so I can go in here and type sol 101. Or I can go down here and do like SPC, and my fields aren't quite correct here, but you could, you know, give it a set ID, and, you know, on node 3, and fixing 1, 2, 3, 4, 5, 6. You know, you could assign all that stuff. Just type it in as you've done previously. Okay, save it and then run it. All right. So that's basically it, right? I won't save it, but there you go. Like I said, you can do it either way. Typically for large models, you have to do a little bit of both anyway. Okay? All right, let me stop there.